Hello, this video is for IXL activity 7.C.21. This activity is titled Multiply and Divide Integers, and its 3-character code is Romeo 8 Delta, R8D. So we've learned in other lessons about multiplying and dividing integers. We learned that if the signs are the same, such as positive times positive or negative times negative, that the answer is going to be positive. And we also learned that if the signs are different, such as a positive times a negative, or a negative times a positive, is going to equal a negative. And the same rules for multiplication are the same for division as well. So let's go ahead and use that strategy and use that information that we've learned in previous lessons, and let's apply it to this activity here. So we start off with a negative times a negative, so we know that that answer is going to be positive. So we'll just put that, we don't have to put the plus sign in our answer, but we will just kind of put that off to the side. And then 1 times 9, well, anything times 1 is equal to itself, so we're going to end up with a positive 9. On the next question here, we have negative 36 divided by 4. Well, let's determine whether the answer is positive or negative first. This is a negative divided by a positive, so the signs are different, so it is going to be negative. And I know that 4 times 10 equals 40. Well, 36 is just 4 less than 40, so that must be 4 times 9. So if 4 times 9 is 36, then 36 divided by 4 is going to equal 9, because if we divide any quotient by or any product, if we divide any product by either of the factors or quotient, or the answer is going to be the other factor. So in this case, we know that 36 divided by 4 is 9. On the next one, we have a positive divided by a negative. So the answer is going to be negative because the signs are different. And a positive divided by a negative is negative. And then also 7 divided by 1, because every fraction problem is a division problem. So this is 7 divided by 1, and that equals 7. And we also know that any number, such as 7 over 1, is going to be equal to itself. So the answer is going to be negative 7. Here we have 1 times negative 3. Positive times negative, they're different signs, so the product is going to be negative. And any number times 1 is equal to itself, so the answer is going to be negative 3. Here we have 33 divided by 11, so we end up with a positive divided by a positive, so our answer is going to be positive because the signs are the same. And 33 divided by 11, well, 11 will go into 33 3 times. And we also know that 3 times 11 is 33. On the next one, we have a negative times a positive. They are different signs, so the answer is going to be negative. And 9 times 4, well, we saw that earlier in the first problem, that's 36. So we have a negative 36 is the product. On the next one, we have 2 factors that are both negative, so they're both negative. That means our answer is going to be positive. And then we have 12 times 9 to deal with. Well, if I think of 12 times 9 as 9 times 12, and then I think of 12 as 10 plus 2, well, 9 times 10 is going to be 90, and 9 times 2 is going to be 18. And then if I add those two together, well, now I need to think of 18 as 10 plus 8. So 90 plus 10 is 100, plus 8 more is 108. So that would be my mental math on that. Many of you might be able to do that in your head, and that would be great. All right, looking at our next problem. Here we have a division problem, and it is a positive divided by a negative, so our answer is going to be negative. And then we have to start seeing, well, how many times will this 20 go into 180? Well, 20 won't go into 1, and 20 won't go into 18, but 20 will go into 180. We can fit, well, a certain number of 20s into the value of 180. So our answer is going to go in this column right here. These would be zeros, basically. We can't put those in there. Nothing worked out for those, but we can go ahead and just eliminate that. Just remember that our answer is going to start in this column here. Now, both of these values, 180 and negative 120 or negative 20, are both divisible by 10. They're both multiples of 10. So let's go ahead and eliminate these zeros momentarily so we can kind of get a better look at this. We're basically dividing both of the both the values are being divided by 10. So we're going to consider how many times will 2 go into 18, and that's going to be 9 times. And then if we want to take those zeros out of the way, that we or put those back into play, you might say 9 times 0 is 0. 9 times 2 is 18. And you see that whenever we would subtract, then we get 0 and we're done. So it is, and let's move this negative sign over a little closer, and our answer would be negative 9. On the next one, we have a positive times a negative. They're different signs, so the answer is going to be negative. Any number times 1 is equal to itself, so 40 times 1 is equal to 40, and the product of 40 and negative 1 is going to be 40. On the next one here, we have a positive divided by a positive, so our answer is going to be positive. And then the next question is, will 20 go into 4? No, it won't. Will 20 go into 40? Indeed it will. It'll go twice. 2 times 0 is 0. 2 times 2 is 4. So we would subtract, and we're just going to get zeros here. Bring down that 0, and well, there's nothing left over. We still have one place value here at the ones place, so we're going to have to put a 0 in there. So our answer is positive 20. We could always double check by taking the quotient and multiplying it times our value that we divided into that number. And look at that, is 20 times 20, does this equal 400? Indeed it does, so we know our answer is correct, positive 20. Here we have 130 divided by negative 10. And this is why I like representing division problems as fractions, because it's a little bit, I think it's a little bit better than using this here. Unless, of course, you don't have easy numbers that end in zeros. The reason why this is going to work out so well is because, well, both of these values are multiples of 10. So if we divide both of these by 10, all right, we could create an equivalent fraction. Let's go this route instead. Let's go back and do this. So let's go ahead and divide both the numerator and the denominator by 10. Oh, divided by 10. And we would end up with 13, and negative 10 divided by 10 is going to be negative 1. So now we've created an entirely new problem right here that's equivalent. These are equivalent to one another. And now we can just simplify this fraction here. Well, this is a positive divided by a negative, so it's going to be negative. And any number over 1 is equal to itself, so we would get negative 13. On the next one, we have 15 times 7. It's positive times positive, so our answer is going to be positive. And we could stack this up and go 15 times 7. Remember, it's multiplication, and this is going to be 35. Carry the 3, and 7 times 1 is 7, plus 3 more is 10, and we get 105. Now, I could have done this mentally and think of 7 times 15, and 15 is 10 plus 5, and 7 times 10 is 70, and 7 times 5 is 35. And now 70 plus 35, well, let's think of 35 as 30 plus 5. And 70 plus 30 is 100, plus the other 5 is going to be 105. So I could have gotten there mentally that way. And the final one is a negative times a positive, so our answer is going to be negative. Now I could stack this up and do 44 times 33, and I could do it using the traditional algorithm. Instead, I'm going to introduce to you a method called the lattice method, and this works really well if you have something like 2,349 times 172, right? So you got to do something like that. Now, most people are going to grab a calculator. I'm well aware of that. But if you wanted to do it by hand, you could use this method here, and it would work out to be, well, there's 3 digits here, so you'd have 1, 2, 3 column or 3 rows of numbers here, and you'd end up with all this. Then you'd have to add it all together to get some big long number down here, right? Well, there's another method called the lattice method, and I kind of like it. You have to create a grid here, and yeah, we'll do a couple examples here. I'll fill in this one here. Better yet, let's go ahead. Let's use this example up here. Let's use this one here. How would I make a lattice method for this big problem up here? So I would first put one number, the first longest number. I kind of like to put it across the top. 2, 3, 4, 9. Notice I've left some space there. And then 1, 7, 2 down the side. 1, 7, 2. And then around it, I would build this like box. And what I want is, I want to have, grab this, highlight that. Let's just undo. Got that one a little crooked. So I want to build a box with columns and rows for each of the numbers. So for the numbers going across the top, I want columns. And then for the numbers going down the side, that 172, I want rows. And then I want to cut everything diagonally. So I'm going to put diagonals through all of these boxes here. And I probably could have got that one up through there. That one's not going to work out too well. So I'm going to put diagonals for all these. Now, indeed, a calculator would probably go much quicker, but I do want to demonstrate how you build the box. Notice I had one over here for this problem. I thought, well, maybe I'll actually show you how to build a box, why the box has a certain number of columns and rows, and why they're all divided. Now, anytime you multiply 2 single digits together, you're always going to get a value that has no more than 2 digits in it. For instance, 9 times 9 is 81. 9 is the greatest single digit. Multiply it times itself, you get 81. 81 has 2 digits in it, a tens place and a ones place. So we're going to do the number across the top times the number down the sides, so the columns times the rows, and we're going to put the answers in the diagonal boxes that match it up. So real quick, let me get a line here and make this one black. So 2 times 1, that answer is going to go right here in this box right here. And we're going to put our ones, or we're going to put our tens place here and our ones place there. All right, so kind of focus on, kind of back up. All right, get all that done and make sure I got my right color ink. There we go. 2 times 1, well, that's going to be 2. And 3 times 1, that's going to be 3. Remember, 0 tens, 3 ones. 4 times 1 is going to be 4. 9 times 1 is going to be 9. Now we're going to do the 2. Now we're going to do 2 times 7, and that's going to go right here in this box right here. So 2 times 7 is going to go in that box there. 2 times 7 is 14. That is 1 tens and 4 ones. 3 times 7, 21. 4 times 7, 28. 9 times 7, 63. So here I have 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. And 9 times 2 is 18. 1 and 8. So now that I've done all that, what do I do next? Now I have to add each of these diagonal columns, you might say. So whenever I do that, I'm going to go this way, and I'm meant to have a line. There we go. So I'm going to go here, 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 right through there. I'm going to add all those going this way where these black lines are, and then I'm going to end up with numbers around the edge. So let's go ahead and take all those lines out, and let's go ahead and fill those in. So 8 would go here. Oh, I want a thicker line. 8 would go here. And then 3 plus 1 is 4, plus 8 is 12. Now carry the 1 up to this other column right here. 1 and 9 is 10, plus 6 is 16, plus 8 is 24, plus 6 more is going to be what, 30? Now carry the 3 up to this column here. 3 and 4 is 7, plus 2 is 9, plus 1 more is 10, plus 4 more is 14. Carry that 1 up to this column here. 1 and 3 is 4, 2 more is 6, 4 more is 10, 0. Carry the 1 up here to this column. And 1 plus 2 is 3. And 1 plus 2 is 3, plus 1 more is 4. And then I have 0 right there. So now, reading the numbers going around this way, we'll list them. 0, we don't need to write. 4040228. Should have an answer of 4040228. Now I'll check that with the calculator. And indeed, that was it there. Got that. There you go, right there. So double check my work with the calculator. And sure enough, it all worked out. So good to go. All right. So with that in mind, all that to do this problem here, but I wanted to show you the lattice method and what I'm using right here. So with all that said, let's go ahead and work this one out here. So I have 44 times 33. So 4 times 3 is 12. And 4 times 3 is 12 again. And 4 times 3 is 12. This one's going to be interesting. And 4 times 3 is 12. Now let's add all those rows up. Going down this way, I get 2. 2 plus 2 is 4, plus 1 more is 5. 2 plus 1 is going to be 4. And then the 1 here. So listing my numbers going down around this way, I would get 1, 4, 5, 2. So negative 1, 4, 5, 2. 1,452. And I'll double check that on a calculator. 44 times 33 indeed is 1,452. All right. So those are all of my examples for IXL 7.C.21, multiply and divide integers, where we are focused on the fact that if the signs are the same, then they're positive. If they're different signs, then they are negative. Works the same for multiplying and dividing. And we even had a nice bonus on using lattice multiplication for multiplying very large numbers. Good luck with your activity.